Hello, everybody, and welcome to today's webinar, Harmonic Damper Inspection and Replacement. I am Amanda Harmonic. I'm an admin assistant here at AERA, and I will be moderating today's event. And joining me from the AERA team is Rob Monroe.
Hey, everybody. Yeah, Rob Monroe here. I look after membership and technical development over at AERA. So just a couple housekeeping slides to go through before we bring on Nick and Brian. Obviously with the COVID-19 situation, all of us here at AERA, we're still going full throttle. So it hasn't affected us at all. We are set up to work from home, as well as we do have some staff at headquarters to help serve you. Our tech line is still open. We're Monday through Friday, 7 a.m. to 6 p.m. Central Time. So all five of us, all techs, we're all there working normal hours. So by all means, if you've still got any tech questions, engine-related questions, membership questions, or anything like that, give us a call and we'll get you looked after there. For those of you, you've probably noticed your third quarter, the July to September edition of Engine Professional magazine has come through in the mailbox. And if you want, you can read the digital version of that magazine. And all you need to do is go to www.engineprofessional.com, and it's there for you to read. Today's presenters are Brian, LeBarron, and Nick Orefice. And hey guys, how's it going this afternoon?
Very good. Thank you, Rob. Thanks for having us on. Likewise, Amanda. All right. Hello, everybody. I'm Brian LeBarron with Vibratech TVD and Fluid Damper. And as Rob alluded to, we're going to be talking about harmonic damper inspection and replacement, but specifically for diesel applications, both light duty and medium duty, and we even touch on a bit of heavy duty. So we're going to cover a lot of diesel tips and inspection intervals and a little bit about the science going into it. I have been with Vibratech TVD and Fluid Damper now for about 10 years. Much of the content development and dealer training originates from the marketing side. So I've had the pleasure of attending AERA regional tech seminars in the past, and some of you may recognize me from there or at PRI. Nick has been with us now for 2 years. If you call into tech support, you're likely to get Nick. He is a ASE certified diesel technician and brings over 20 years of experience to us. Very, very knowledgeable when it comes to all types of engines, but specifically for diesel applications. For those who are not familiar with Vibratech TVD and Fluid Damper, we develop and manufacture viscous type harmonic balancers for OEMs and professional motorsports teams. On the OE side through Vibratech, we work with about 30 of the leading powertrain and tier 1 manufacturers globally. On the motorsports side, Fluid Damper has been around since 1985, and we've been race proven since. Currently today, the most well-known team running Fluid Damper now is Corvette Racing, and they do very, very well in the 24-hour series with Fluid Damper. Fluid Damper is 18.1 spec for professional racing applications. We're located in Springville, New York. Everything we do is all sourced and manufactured, everything designed right here in the United States. Springville is about 30 minutes south of Buffalo. And at the 120,000 square foot facility, everything is we're highly skilled craftsmen and CNC machinists, and we also are ISO 9001-2015 quality systems certified. Again, high quality, advanced American manufacturing, all sourced USA materials. So we're very, very proud of that. In the latest issue of AERA Engine Professional is an article that I wrote, worked with Rob over that in the springtime about diesel damper inspection tips and tricks. They've been saying that they've been getting more interest in the diesel engines and ways we can get durability out of it. So again, collaboration with AERA, wrote up a lot of knowledge that we have internally and to get those recommendations out to you guys. So with that, we have our first poll question. And just to get an idea of where you're coming from here, and that is how many light and medium duty diesel trucks do you service per month? And would you say is that trend growing, steady, or declining? And I believe Amanda can help us get the polling done.
Yep. All right. I've popped that up here. Go ahead and select. You can select all that apply. So if you have more than one answer, go ahead and fill that in there. So it looks like Approximately 42% of you have 1 to 5. We have 19% at 6 to 15, excuse me. And 16 plus is 12%. And then I see also that 50% of you said that your trend is either increasing or steady, with 15% of you saying it's declining. So thank you everybody that participated. And we'll go ahead and close that out and hand things back over to Brian.
Great. Thank you so much for chiming in on the poll. It's very, very useful information. Well, I can show you here, as far as fluid damper product sales go, we have been steadily increasing diesel dampers over the past 10 years. It has actually tripled in production volume. Diesel performance now accounts for about a third of our sales. So over the past 10 years, we've really seen that truck market keep climbing and climbing and climbing. And I attribute a lot of that to just the multi-purposes of a diesel truck these days. Not only do we see it for, in racing applications, but also just work trucks. Those are using it for contracting services or hauling, or you own a good diesel truck, you want to get as much as you can out of it, and you're going to use it for your small business. And it's not uncommon to see some of those guys, at the drag strip on a Saturday, where they're just using the same truck. So they want to get as much mileage and as much durability as they can out of it. And that's where the damper comes into play.
And another note on that, the Cummins damper, or the Cummins engine itself, has actually kind of become the small block Chevy of today. A lot of people are using them in swaps and different other applications, and also in industrial applications. So the damper is an important piece, and often overlooked, but definitely an important maintenance item and upgrade.
So we're going to dive into the meat and potatoes of the presentation today. We're going to break this down into 3 sections. We'll talk about the types of diesel harmonic dampers, why we have inspection and service intervals, diving into not only what the service intervals are, but why they're in place and what's happening on more or less the science side of it. And then we'll get into the performance diesel installations and things that you're going to need to be aware of if you're doing performance work to a diesel engine. And with that, I'm going to turn it over now to Nick, and he'll get into talking about the types of diesel harmonic dampers.
So yeah, so we have 2 main types with the diesel dampers. There's your factory style that are the elastomer dampers. Cummins uses an internally balanced damper, where Power Stroke and Duramax, they use externally balanced dampers, and that is where the term balancer kind of comes in. So it's a damper and a balancer. Often intertwined, used the same way, but an externally balanced damper does do some balancing along with the rotating assembly. And then so the elastomer damper has 3 main pieces. You have your flange, your hub, and that's what mounts to the crank itself. And then in between that is the bonded elastomer, and that's what holds the tuned inertia mass, the outer ring on. And as they wear, the inertia ring can actually separate and come off. I've seen it myself, but I've also talked to a lot of people, especially lately. They're overlooking this item, and it comes off, and that actually can become a little bomb under the hood and swing around and do some damage to other components. So it's pretty important to check that and inspect it. Now Cummins and the 6.7 from 07.5 up, they switched over and they're using a viscous damper. It's same principle. It's got the mounting flange for the crank, and then that includes the housing. And then you'll have your inertia ring that's inside, and then silicone is actually inside there. It's pumped in through the fill plugs, and then the cover plate is welded over top of that to seal it all up. In this picture we're showing here, this is one of our dampers. It's a cutaway showing the shear gap. That's where the silicone lives. You can see the inertia ring there. and the silicone is 45,000 times thicker than 30-weight motor oil. So it's the little picture there showing the nickel on top of the silicone, the thickness of it. Sometimes people think it's really thin, or we'll get comments. I actually had a guy told me it was BBs, but it is silicone, and it's not a lot of silicone. It's just in the shear gap there, as we're showing. Now the main difference, obviously, one is viscous, but OEs tend to use the elastomer because of the price point. They're cheap, and that's how it is, often built overseas by the lowest bidder. But elastomer dampers, they have a narrow range for the harmonics, or what they target, and the OE will target the most harmful of vibrations, the harmful resonance. So it's just tuned for one specific frequency, and they really do have a short life. They dry rot and crack and susceptible to oil. If you have a 12 valve, they leak oil, so that just kind of helps deteriorate it even faster. Now, a viscous damper, it's more of a premium cost, but with that, it lasts a lot longer, and it has a much more broad range for the tuning out the frequencies. And one of the benefits with a viscous damper is that it is able to tune itself in real time to the engine's harmonics throughout the entire RPM range. Now, this is a little hybrid, a little bonus damper. So it's actually is a viscous damper from a BMW 335, and it has a rubber elastomer damper built into it as well, and that is for the accessory drive. Kind of a little of a hybrid option. Don't see too many of them, but BMW did find the need to run one. So when to upgrade to a fluid damper, when you need it is especially important anytime you change the rotating assembly, any kind of hard parts like that. It's going to change the natural frequency of the engine, so that you do enough stuff, it's going to actually just make the stock damper not even do its job anymore. Good time for that, or anytime you're doing that, you would need to look into getting a viscous damper or a performance damper. When you want to upgrade it, any parts that increase torque, the horsepower, it's going to really weigh on that stock damper, and it won't last very long. It'll actually deteriorate it even faster if it hasn't already begun to fail. It's really going to kind of take its toll much quicker. The why to inspect it, I believe, Brian, you're going to take this section here.
Sure, we'll dive into why we have these inspection and service intervals. There's a reason why they write those into the owner's manuals, and a lot of it gets down into material wear and how it occurs and what's going on. So I'll take over this part here, and I'm going to lead things off again with another poll question, and that is, do you currently inspect and replace a harmonic damper according to service recommendations? And the second part of that is, do you install a new harmonic damper with engine rebuilds?
All right, so we're going to launch the first half of that here first, and I'll go ahead and give everyone a moment here to answer. And so it looks like 58% of you said yes, and 42% of you said no. So on to the second part of that question. Do you install a new harmonic damper with engine rebuilds? Go ahead and place your response in there for that one. And thanks again to everyone that participated in these polls. We're going to go ahead and close this one out. And on this one, it looks like we had 53% of you said yes and 47 said no. So thank you again. And I'm going to hide that and get it out of the way, and we'll hand things back over to Brian.
Great. Thanks, everybody, for chiming in on that. A two-part question on that, and focusing on that second one, installing a new harmonic damper with engine rebuilds. If you have a fresh rebuild and you put a worn damper on it, you may find that it's going to accelerate the wear of those new parts even quicker. So we always recommend a new harmonic damper with a new engine rebuild, just so everything's fresh and on par and things are going to wear like they should. Okay, and then moving on to some of those inspection intervals and tips. Now on the elastomer dampers, we see that the rubber material starts to wear out. Now different OEM manufacturers of elastomer dampers have different blends and types of rubber that they put in there. Sometimes on heavy duty diesel, industrial diesels, it holds up a little bit more, but we find that the wear patterns are all the same. And they start seeing around 30,000 to 50,000 miles, or about every 2 years. If you get in with a close inspection and start looking at the rubber, you'll see like hairline fracturing, and over time that will gradually open up more and more and more till you get to the point where you have we call it a failure, where the elastomer is chunks of it are missing. It has exploded out of the seam here. As Nick mentioned when we first got started, this could be a safety hazard on the road, definitely at the racetrack, if this outer inertia ring separates from the hub and grenades inside your engine bay or rolls out from underneath the car. So again, if you're not doing a service inspection on the harmonic damper, you absolutely should, especially for performance work. Now, some of the causes besides mileage and age that will help wear that rubber out is exposure to oils and solvents. Again, if you have a front main seal leak, or you get oil on that, or any type of cleaners and solvents, it can wear down the rubber as well too. Another cause of premature wear is excessive power. Everything has its limits. So if you're building up diesel performance, pay particular attention to the damper, because it will cause that damper to work harder, work more aggressively, and that can accelerate the wear of the rubber as well. Now, viscous dampers are a little more challenging, and then for years we've heard that one of the downfalls of a viscous damper is that you don't know when it's wearing out. But in fact, we do have service recommendations and tips that you can do to get a gauge on that without having to cut it open. Because obviously, once you cut the damper open, it's no longer usable. So on viscous dampers, a lot of this we took from our own experience at Vibrotech TVD and Fluid Damper. As the damper does start to wear around on heavy duty engines, on Vibrotech dampers, when they start wearing about 500,000 miles, you see the silicone start to break down in it. We'll get in a couple of slides in that and show you some demonstrations. But also telltale signs besides mileage and age of it. Any point where you see a bulge or raised cover in spots, if you take a micrometer and measure the outer housing, if you notice a gap that's more than 2 thousandths, that may be indication of something going on inside the damper. If you're running the damper in extremely hot conditions, deserts, for long periods of time, you can get outside heat playing a factor in that as well. Again, if it's been dropped or damaged, as you saw in the cutaway, there's not much space between the inner inertia ring and the outer housing. So if you get a dent in it and it locks that inner inertia ring, the damper is not doing its job. A couple other tips for our viscous damper: if you find that you're throwing or slapping belts, the damper may not be quite functioning the way it should. If you notice any excessive wear to bearings or rotating assembly components, if you see accessory brackets fracture or crack or bolts back out of that, that's all kind of telltale signs that there's something going on with the damper. Now, as we talked about a little bit before, inside the damper is polydimethylsiloxane. That's a really long word for silicone. And silicone is made up of carbon with 3 hydrogens bonded by silicone and attached by oxygen in a very long chain. And what we find with silicone is that it's very thermally stable, more so than oil. It holds its viscosity across a very large temperature range. And it also comes in very large viscosity types, anywhere from about 10,000 centistokes to 1,000,000 centistokes. We kind of translate that to say that it's about 45,000 times thicker than 30 weight motor oil. Now for Vibrotech TVD and fluid damper, we use a highly refined proprietary blend of silicone. And that's how we were able to achieve the 500,000 mile service intervals on the heavy duty dampers. And for fluid damper, it's overbuilt. It's good for the life of the engine. But like we say, everything has its limits. And then silicone does break down. We do find that is the case with Vibrotech dampers at about that 500,000 mile mark. Or if you have a lower quality OEM type damper, this could also happen in that as well. And then in those cases, you're inspecting for bulging on the cover, overheating, such like that. And what's going on inside the viscous damper is the shearing of the fluid. Over time, those oxygen links break down, the strands of silicone break down, and they start forming up in these glue spots. So what I have here, if I can see, this is a jar of clear silicone. This is fresh, brand new. You can see right through it. Here's one that is got about 20,000 hours on it. Came out of a stationary gen set. And in there, you can see somewhat of a brass ball dropping through, but it's all cloudy. And we have this big glob of black here. That's polymerized silicone. You let that go long enough, and you end up with a powder. It totally breaks down and forms into like this powdery rubber substance. Now, there are instances where that can happen a lot quicker. If you have increased operating temperatures, again, if you're running in the desert on road trains, long haul trucks going 24/7, that high ambient temperature and also the constant lugging of the engine, it can't, the damper itself can't dissipate that much heat, generated from the damping out through that outside ambient temperature. So that will accelerate the wear of the silicone. And then if you don't have a highly refined blend of silicone and you get more oxygen in it, that will help speed up the process and you get the polymerization going on even more. Older viscous dampers where they would run metallic bearings inside of them, you would get dissolved contaminants from the bearing, breaking down those chains of silicone and causing things to go up and polymerize faster. So really it comes down to quality, and we're operating within the proper specs. Again, we see this mostly on the Vibrotech line of dampers because they are in industrial and commercial use. You over the road, your 3/4 ton pickup trucks and such, you may want to look for this on performance type applications with stock dampers. And the best visual check we have right now on a viscous damper like that is to look for the bulged cover. Again, take a mic, run it around the outside housing. If you just notice a gap that's more than 2 thousandths between spots. Here's a good example of an industrial one where the cover would just bulge right up. Then you know that those glue spots, those polymerized spots of silicone are forming inside the damper. It's causing pressure. It's causing disformation in that in that shear gap. And there's not a lot of room there, so there's not much where that polymerized silicone can go. Eventually, like I said, it will harden. It will lock that inertial ring, and then you know that the viscous damper needs to be replaced. A few other quick tips with the viscous dampers. When you're installing them, make sure that the belt tension is set properly. If you over tighten the belt and you get that viscous damper running at an angle and start orbiting, again, you saw the cutaway, there's not much room in there. And if you have internal contact between the inertial ring and the outer housing, you can friction weld the inner housing or the inner inertial ring. Likewise, if you have a lot of axial vibration and you have that inner ring slamming against the housing, you get that internal contact, you can get friction welding and you can lock that inertial ring. Now, in known cases where we can anticipate that, Vibrotech TVD and fluid damper, both, we can put proprietary non-metallic bearings inside of there and take care of that internal contact. So again, older engines, particularly stationary engines, industrials, watch your belt tension. On the last, on the heavy duty checks, and even if you can do this in the shop with a pickup truck or a race truck, if you can get to the front of the engine and get a temperature check on that, An elastomer damper and a viscous damper will both generate heat as they're damping, just the working of taking out those vibrations. So with the viscous damper, it's going to act as a heat exchange. It's going to dissipate that heat out through the outer housing. So if you have a baseline temperature, and then you can do periodic checks on that and see that, ensure that it's running hotter than the baseline, then you know that it's working. If you find that it's gone cold and you're not getting heat dissipating off the face of the damper, then it's a sign that the silicone inside is polymerizing. Again, a lot of these tips are all also in the reference materials to download. You can call into Vibratech TVD and Fluid Damper. We can help you out on the tech lines as well to kind of walk you through those service intervals. And with that, I'm going to turn it back over to Nick. He's going to talk specifically about diesel performance.
Thank you, Brian. So with the diesel performance, right now Cummins outselling Duramax and Power Stroke engines. We're going to kind of just go over the specific application here, which is a Cummins engine. The flange itself of the damper, you have to watch to make sure that the bolts don't come loose. With that, you can get, with the high torque of the engine, you can get wallowing of the bolt holes where they actually become egg-shaped right here, and which would allow the damper to move. And the common rail engines, they have the alignment pin in them. A lot of guys will end up shearing those off, and they have to get them out or drill them. They are just pressed in, and you can replace them. You can buy new replacement ones, and they are very important to have that in there because that aligns up for your timing. All of our dampers in the fluid damper line are SFI certified, so they're made to handle the abuse. And as Brian said, fluid damper is way overbuilt, so we're making sure that it's going to handle the power everybody's throwing at them. And we constantly monitor, how everybody's doing with everything, and if things need to be changed. We do listen to the customers and make sure that we're keeping up and make sure everybody's getting what they need. A great case in point right here. In 2017, customers were having some bit of issues. There, a lot of guys are stock dampers breaking the flange. So with the horsepower and the torque going up, we added a more thicker, more robust flange. We also tightened up the tolerance for the bolt holes. One of the other revisions that was done back then was this radius right here to allow for belts to be removed on and off. Mainly in a stock application, who's running, the stock fan and all that, or the stock accessory drive. The guys that are running gear-driven pumps or aftermarket cooler fans, they don't have that issue just because there's more clearance available. The drill pin kit. So the guys that are running anything over 3,500 RPM. So basically, if you're turned up over stock, we definitely recommend having a drill pin kit and get one of those pins in. This kit here is specific. We only have one for the Cummins engines. The fluid damper does allow provisions for one pin on the common rails, and the 12 and 24 valve dampers, we have provisions so you can put 2 pins in. There are guys that will run extra pins. You would have to drill a spot for it. We don't have, we only make a hole for one on the common rail engines. Securing it to your engine. Now, we recommended anything over 700 horsepower. This kit was actually developed with the guys from Fire Punk to help lock on the damper. We have our diamond encrusted friction washer right here that goes between the damper and the crank itself. And we include a torque plate that goes on the front and actually has a machined finish on the backside that helps to bite into the front of the damper and give full clamping pressure. And these are ARP bolts that are made specifically for us. They're extended length, so they come in that kit as well. A lot of times we'll get some customers that call up and they're asking, what do you recommend? What do you recommend? And I always try to steer everybody towards this full power kit as for the bolt kit itself. And not only is it a great piece just for the fact of you get all these parts and it's going to be on there and secure, but you get on the torque plate itself, there's a 5/8 hex head. So it can help you bar the engine over if you're adjusting valves, you do some maintenance, or just trying to roll the engine over for whatever. The little tool built in there, so you put a 5/8 socket on there and you can just roll the engine over. But yeah, I would recommend that anywhere from stock all the way on up to 1,000 horse plus, whatever your goal is or whatever you're going after. But so that's a great little piece there to help secure your investment. You don't want a damper coming off, especially on the racetrack. New this year, we actually just released this one. This is my little baby. I'm a huge fan of tractor pulling, and I'm a tech inspector, SFI tech inspector for the PPL League. The new damper here is for tractor pulling specific. It does require the taper lock hub, which is the 12 bolt holes, a 4.5-inch bolt circle with a 3 1/4 pilot. So that it does require a special hub for mounting. We do not manufacture that. We have a lot of our dealers for the tractor pulling stuff. They manufacture their own, and these can be purchased through any of them. Another great thing with this one is this is the first SFI certified tractor pulling damper. This is our largest damper that we make. It is solid billet steel. So that is like I said, it's the largest one that we have. But so that's a great piece, especially if you're into pulling. Not recommended for your little Cummins engines. This would be a full-out John Deere or International tractor, or like a big cam Cummins, something that you're using for pulling. So that's it. I guess anybody has any questions, thank you guys for listening in. And if there's any questions, ask away. We'd be glad to answer them.
Super, thanks guys. Great presentation. Got lots of good information there. I know we do take calls in the tech department about dampers and about the lifespan of dampers. So I'm glad you covered that. That was some really good information. Yeah, some couple questions come in, and I'll let you guys decide who's going to answer them. But first question I got is, can a fluid style damper be balanced?
Nick, do you want to take that one, or you want me to?
Sure. So our dampers are all balanced right here at the factory. They're all precision balanced. So when they leave here, if it's external, it's balanced to be, that counterweight. But in internal balance, they're 100% neutral balance. You can't run a balancer on a rotating assembly balancing procedure. With the inertia ring always moving in there, you will always get a slight imbalance. It takes the torsional vibrations to excite that inertia ring to get it to center, and the rotating assembly doesn't get any torsional vibration when it's on like a balance machine. So you'd just be spinning it. So you'd always be chasing a slight imbalance. So you would need to use like a stock elastomer damper or a solid mass to get that properly balanced.
Okay, excellent, super. Another one's come in. What would the wear one could see on a high horsepower engine other than what was shown?
One thing to look at, I guess, on the high performance side of it too, is other components in the engine. Particularly the main bearings. If you start seeing like accelerated wear on that, that's a sign that the damper's not quite doing its job. Again, look at other little, I would call them gremlins almost. is the belt slipping? You cracking accessory brackets, bolts backing out. Some of that can be traced back to a vibration issue, and you may want to take a look at the damper.
Another thing on that, as the damper gets worn, especially in a manual a manual vehicle like the Class 8 trucks, the shifter, the cab, like the driver will feel it more and actually give driver fatigue. So it's something there. You can feel it through the drive line as they're pretty much spent at that point.
Okay, all right. Another question for you. What is the best method to install a harmonic damper?
Making sure you have the space, the room to do it, trying to not, I'm guilty of it myself. You try to cheat and get it out as easy as possible. But if it's one that goes on to the snout of a crank and you don't get it lined up straight, you could be asking for some serious trouble. You could remove material from the inside of the bore of the damper if it doesn't go on perfectly straight. But any mounting surface, whether it's like a snout of a crank or the flange, you want to check it for wear, make sure that there's no burrs, nothing uneven, clean. And then if it has a snout like the old Power Strokes or the Duramax dampers, even though the Duramax damper is technically a slip fit damper, put a little bit of anti-seize for just to help it go on, make sure that everything is good, and then not over torquing it. Getting the torque right is a big deal. A lot of guys, you call up and, can I reuse bolts? A lot of bolts are torqued to yield. So I always like to recommend ARP, just having a better secure bolt, but having the proper hardware is a big deal as well.
I'm going to jump in there with a plug too. As Nick has mentioned, always use a proper harmonic installer and puller tool. Fluid damper here, we make our own in-house, and we made it for shop use. It's intended if you're pulling dampers day after day after day for years, this kit is designed for that, where it's going to outperform and outlast even the high quality parts retailers. So again, if you're looking for a high quality puller and installer, check out the one that Fluid Damper makes. It's well worth it. And again, it's all machined in-house.
Okay, excellent, guys. Yeah, thank you. Another question. Is it recorded with the engine serial number about what damper was installed to help with replacement and reduce vibration?
On an OE level, I guess if what you're asking, what I think you're asking, like on a semi truck, it would be based off the engine build. For your regular cars or diesel pickups, rather, the damper is specific to that engine. So if like Duramax has a couple different counterweights, so it would be year specific, not so much, I guess, part number specific, or maybe I'm saying that wrong.
Okay. Yep. No, I know what you're getting at. It's probably the best to go off of engine serial number, or something like that, rather than or year and make model, basically, rather than, let's say, because who knows, that engine could be a totally different part number in another vehicle or something like that. So,
Right.
yeah. Okay, going back to balancing just real quick, another question. So they're just to clarify, they're asking, so to balance a crank, you're saying to balance with a stock damper. And I think they're referring, probably going back to, not putting on the gel filled or the fluid damper for balancing. So they're saying you're best to balance with the stock one?
Right. Yeah, the stock a stock mass damper, whether it's external or internal balance, not a non-viscous damper.
Okay, so basically, don't put the viscous damper at all for balancing. It's gonna the machine will go crazy, kind of thing.
Yeah,
You'll constantly chase an imbalance.
The balancing machine can't replicate the conditions of torsional vibration, which is the end-to-end twisting of the crankshaft. it's designed to take out rotational vibration, which is like what you have like on a tire or something that's weighted out of balance. So the viscous damper needs torsional vibration to get that the inner inertial ring moving and centered. Now, like you look at that cutaway, there's not much room there to go. So we hear this a lot when it comes into like high RPM applications and such. But what I can tell you that we have on the OEM level pushing hypercars at 11,500 RPMs in half a second. It's not an issue. There's so little play in that shear gap and in that distance, but again, it needs that torsional vibration to get that inertial ring working and get it where it needs to be, and that happens very, very quickly.
Okay, yeah, no, good explanation, thank you. Are the fluid damper or gel-filled vibration dampers rebuildable?
Brian, do you want to take that?
Sure, I can take that one. Some industrial and commercial viscous dampers are either refillable or rebuildable, and that could lead into a whole nother topic just on industrial and commercial dampers. But there's a couple ways to know that if it's refillable, it's going to be built with oversized bearings in the inside, where we can then pump out the old silicone, pump in new silicone. We do that for some OEM customers in the railroad transportation industry. And then you get into really huge viscous dampers. We're talking some that weigh about 56 inches in diameter, or even down to about 24 inches. And with those that are truly rebuildable, where you can pull them out, install new bearings, and fully refurbish them, you'll find that those will have a bolt-on outer cover. So again, it gets into a couple of little different design variations, but certainly if you're in rebuilding industrial and commercial engines, just hit us up after the webinar. We have plenty of other resource materials just for servicing those, and what to look for is design-wise to know what you have.
All right, super. Okay, another question here for you. They're asking if they've got an older Cummins damper, how can they check if the flange holes are starting to wear?
If it's a stock damper, I mean, really, the only way to check it would be to use like a set of calipers. But if you had, I mean, I guess you could use like a steel slug or something to check to make sure that they're still round. I mean, when they start to go, you'll notice it. You'll start to get like a mush half moon impression on one of the ends of it. But I know a lot of times I went for a Cummins training class, and they told us that the inspection replacement interval for the older Cummins engines is 30,000 miles. Nobody follows that, nobody does that, but that's their kind of scapegoat because the dampers were just kind of garbage. But I mean, I've talked to guys that say they got 200,000-300,000 miles on their damper and they think it's fine, and then they swap it out and they're like, oh, I guess it was bad. But just for the holes itself, I check for any kind of metal transfer or missing materials.
Okay, excellent. All right, well, just to respect everybody's time, if you do have any more questions, what we'll do is we'll get those over to Brian and Nick over at Vibratech, and they'll answer those for you. Guys, that was an excellent presentation. Thank you again for your time. I know it, to piece one of these together, it takes quite a bit of resources and time and that kind of stuff, and you guys did a great job, so thank you very much. And like I say, yeah, no, it was great. And like I say, any more questions that we have, we'll get those over to you, and Brian and Nick will make sure to get those answered for you. So you guys have a rest of your good afternoon, and I'll go back here to Amanda here for just half a second, and we'll just sort of wind things down here for you.
All right, thank you very much for having us.
All right, couple
Thanks,
quick
guys.
things here. First off, when you go to leave the webinar, there will be a survey that pops up. Please take a moment, fill that out. Let us know if you have any additional questions that didn't get answered, how we're doing, if there's anything you'd like to see in the future from us, that kind of stuff. You will also receive an email tomorrow that will contain a link for today's webinar that is yours to use as you wish. You can rewatch the webinar. You can pass it along to others you feel would benefit from it. Do with it as you would like. And lastly, you'll see our contact information there. If you call 815-526-7600, you will get the entire AERA team, and you will see my email address is listed there, as well as Rob's, along with Steve and Karen. Any of us can help you if there's anything you need. Feel free to reach out to any one of us, or go ahead and just reply to the emails you get from GoToWebinar, and those will come straight to me. So thank you again, everybody, for your time. We appreciate it, and we hope you all have a great day.